And my first guest this week joins me in studio, Mr. Tom Djokovic. He's the CEO of XSNX, stock symbols XSNX. It's been a while, Tom. Good to see you again.
It's great to be back, Don. Thanks for having me.
Now, we've been following your company for a number of years. We've seen a series of evolutions of the business model. For those who are seeing you for the first time, because it has been some time, why don't you tell us again what XSNX is involved in?
Well, Don, what we're doing is we're in the solar space, and we're developing a new kind of manufacturing technology for a thin film solar technology called CIGS, which is copper, indium, gallium diselenide. It's a couple of metals that you combine together, and they create an absorber that captures sunlight and turns it to electricity. It's called a thin film, and it happens to be one of the most promising thin film technologies out there. In the laboratories, they're getting close to 20% efficiency. Unfortunately, on the manufacturing floor, they're getting closer to around 10, in some instances as high as 12. So there's almost 100% unused potential, untapped potential there that's laying around waiting to be tapped. And we believe that the manufacturing technology we're developing has the opportunity to potentially tap that unused opportunity.
Now, you had once mentioned on the program that this CIGS technology, this manufacturing technology, was originally based on the hard disk drive technology?
Well, no, not really. What we're doing is, and this is something that's growing in prevalence, and you kind of, I think a lot of people might be able to understand what I'm about to say by looking at what the space program did. A lot of great technologies came out of the space program that were never designed for where they're being used now. The automotive industries, electronics, internet, you name it, and the same thing's occurring now. There's a lot of great industries out there that have spent a lot of time, a lot of very intelligent people develop interesting processes that have reduced operating costs, increased efficiencies of products, improved things across the board. Hard disks is one of them. If you look back 10 years, the cost of a hard disk relative to its amount of memory was through the roof. Now they're dirt cheap. Yeah. The industry's had to undergo a tremendous amount of price erosion, and they've succeeded. They've done it. They've really met the challenge. And what they've done is some of their processes are similar to what you use in thin film solar manufacturing, sputtering techniques, material handling techniques. And we're borrowing some of that. We're saying, hey, look, what they learned, those lessons learned are very valuable, and they're applicable to solar. So we're borrowing and adapting some of that technology with solar technology to create this entirely new manufacturing process we call SIG Solar.
Now, when it comes down to the viability of solar as an energy generator, it really all comes down to the cost per watt produced, right? I mean, it's really down to getting down to money at these days.
Absolutely, absolutely. It is a cost per watt, and the neat thing about SIG Solar, and this is what a SIG Solar cell would look like. It's on stainless steel, and these are the collection grids for the CIGS solar cell. What's interesting about SIG Solar is with its upper potential of being close to 20%, that's close to what silicon does. This is a silicon solar cell. This happens to be a 4-inch square silicon solar cell. It's going to produce somewhere between 13 to 15% efficiency in the solar panel. Unfortunately, right now, the thin films, while they're less expensive to manufacture, they have lower energy densities. And most of your thin films out there, like I said, are between, well, they start from 7 and go to maybe 10%. There's some that are starting to reach 11, 12%. So they're less expensive to manufacture, but they have less energy density. And what's happening with our process with SIGs and SIG's untapped potential, if we can succeed with this process by making the manufacturing area smaller, and using the hard disk drive industry's ability to rapidly reproduce this, by keeping it smaller, we can better control the processing area, get tap more of that unused potential, get efficiencies closer to the silicon, 14, 15% efficiencies, but still benefit from the low-cost manufacturing techniques, the lower material costs and low automated processes associated with thin film. You combine the best of both worlds. You now produce a technology that has an opportunity to really offer, to be a substitute for silicon solar cells. They control over 80% of the market. That's a multi-billion-dollar market opportunity to swap out silicon with CIGS. And secondly, to offer something that's truly viable in terms of reducing costs. And that's our goal.
So the whole thing really comes down to the ease and the low cost of manufacturing. If you can essentially stamp these out like the computer industry stamps out hard drives and do them in huge quantities at a low price, while still achieving the efficiency rates you're looking for, you've essentially hit a home run.
We've hit a home run, but it's not stamping. There's definitely a manufacturing process. They lay down thin films, as a matter of fact, much thicker than what we do, and I mean thinner, and so you know, we're still borrowing. There's still a tremendous amount of benefits. And even the U.S. government recently, there's a grant we recently applied for in which they were specifically looking for companies that were going to reach out, and what they call it cross-industry efforts, where you reach out into other industries, pull the benefits learned from those industries over into the solar industry and see if you can develop better products, cheaper manufacturing methods. And since we're in that, we're doing it, we thought it was very applicable, so we applied for it. And hopefully we'll get it. You never know. There's lots of great companies out there that apply for these things, and you never know what makes up the decision makers' minds. But nonetheless, the government's seeing this opportunity as well.
Now, again, we're talking with XSNX, stock symbols XSNX. If you'd like more information, please call us toll-free from anywhere in the world, 888-259-4449. Now, Tom, you kind of segued into my next question, because, of course, in this level of research and development that you folks are doing for this technology, obviously that's capital intensive, and so you mentioned you're applying for grants. What other things are you doing to fund these operations?
Well, we're a small public company. We trade on the over-the-counter market. To date, what we've done is there hasn't been any revenues. We've been funding it through equity placements. Our plan right now doesn't incorporate the use of the government funds to complete this project. We recently announced a $5 million financing with a group out of Chicago, equity financing line, and that's in place to help us fund this further. At the same time, we're hoping to enter into sales as soon as possible. Our president and CEO is Joseph Grimes, has also been actively engaged in lining up potential licensees of this technology, and we're hopefully going to be entering into some several MOUs in the near future as soon as we can complete and start producing and delivering samples of this technology here, hopefully in the next several, we'll say 6 to 8 weeks approximately. We're hoping we can maybe convert some of those MOUs into definitive contract negotiations. So, you know, hopefully we can move into revenues as soon as possible. But right now it's primarily being financed through equity placements.
So basically, you're in a position now where you're showing potential clients the viability of this manufacturing process and what it can achieve, and then essentially you would be licensing this manufacturing technology to manufacturing companies. You wouldn't actually be manufacturing yourselves.
That's our plan right now, and the reason for that is there is a lot of infrastructure already in place for companies that we call aggregators, where they buy parts and pieces and they assemble it. Very few companies actually make their own solar cells. They buy them and they assemble them into finished products such as a solar panel, and they put their name on it. And so there's a lot of infrastructure already out there in place for that, and people with physical presence, both in the communities and the business and government environment. They're capitalized. They already have infrastructure, employees, brand presence, service infrastructure, things like that. We believe that by licensing this technology and earning a small royalty on the amount of product produced is going to be a faster way to deploy this into an existing very vibrant market, and number two, less capital intensive for XSNX. At the same time, it doesn't prevent us from in the future potentially building our own facility, but right now we believe that we're going to best serve our investors by deploying through this method, and also the technology, more rapidly deploying it.
Of course, there's probably nothing that's getting more attention right now in the public company space than companies that are involved in green technology. What about competition? Are there other companies out there that are trying to do the same thing you're doing, or are you pretty much in your own space? What's the situation there?
Don, we're not aware of any other company that's specifically doing this, and let me detail that. What we're doing is we're combining what's called sputtering techniques, which we're deriving from the hard disk drive industry, with what's called co-evaporation, the actual boiling of metal into a vapor, combining these metals and then having them literally deposit onto the surface of the solar cell to create the CIGS member. The evaporation method is the method that's proven to develop the highest efficiencies, the lowest operating costs to produce, lowest material costs. Conversely, on the other side, it's been the most difficult to scale. Most people develop this size in laboratory, and then they try to develop large area deposition processes to compensate for the need for mass quantity in a commercial environment. We're keeping it small, not scaling. We're hoping to avoid all the problems associated with introducing all kinds of variations that create what's called pinhole defects, reduce the quality of the membrane, keep the efficiency higher, and leverage those hard disk drive manufacturing, material handling techniques and things like that to maintain the throughput and the quantity. We're not aware of any other company that's currently engaged in that effort.
If your efforts prove successful with the technology, is it an intellectual property that you are then able to achieve protection for, or how would that work?
Well, we believe so. I mean, method and apparatus. What's interesting about what we're doing, and I mention this quite often when I talk to people, is it's not necessarily new science. Very few people want to invest in new science, where you're going to go out and invent something entirely new. What we're doing here is essentially better engineering. We are taking processes that have been around for a long time, and we're using those well-known processes. We're just packaging them in a different delivery method, different manufacturing system. That method apparatus aspect, we believe, is definitely probably can be protected under patent law.
Like I tell them, this has been an education.
Sure.
Probably one of the most technical interviews that we've done since we've been following your company. We are reinitiating coverage of your company this week. Be following you for the next several weeks.
Right.
Looking forward to more updates, especially as you mentioned, 6 to 8 weeks. Like to hear how that transpires. Thanks for joining us on the show again.
Thanks, Don.
Take care.